All right, folks, it is the 3rd of October, and I'm kind of writing that up here because we're going to spend a couple lessons on slope. This is going to be kind of weird because today we're going over slope. We're going to start it, and then we're going to pause on chapter 2 so we can take our first test. So next week is all about the test. We'll review. We'll take the test, and then when we come back the week after, we're going to come back to this lesson and review it again. So we'll kind of pick up where we left off today. But I'm sure we'll have to review a couple things because it's going to be like almost 2 weeks in between. But you guys got this. There's a major mistake on this. Holy cow, how did I miss that? I got to fix that. Okay, let me fix something here. Would you guys please scratch this out right here? It's a little triangle X, triangle Y. That is totally backwards. It's supposed to be triangle Y, triangle X. And that triangle in math, we pronounce that as change. That's the change in Y and change in X. All right, our learning target for today, we want to use the language of linear functions. Linear functions have equations like the ones that we saw in our last lesson. We want to use the language of linear functions to describe and make connections between different representation. Big target for today. When you look at a line, can you tell whether it has a positive or a negative slope? How many people think they already know how to do that? Give me a thumbs up if you're feeling pretty good about what a positive and a negative slope looks like already. A couple people feel like they got that already. We'll check it. And then we're also going to learn how to make slope triangles and start thinking about slope as change in Y over change in X. So we'll come back and we'll give ourselves a grade at the end of today on how we're understanding. But keep those things in mind. Positive versus negative slope and slope triangles. All right, if you guys would flip to 2.1.2. The other topic that's going to come up today is this idea of steepness. You guys know what I mean by steep, right? If you're on a hiking trail up by Mount Baker, those trails get pretty steep. But if you're just walking along Main Street, there might be some small hills, but they're very steep around here. All right, let's start by reviewing what we did in our last class. We're going to write an equation for this tile pattern. So they didn't show us the actual tile pattern, but what they told us is that in figure 1 there's 7 tiles, in figure 2 there's 12, in figure 3 there's 17. Do you guys remember? Try to do this without looking at your notes from last class. Do you remember how to write an equation in that format? And if you're not too sure, that's okay, because we just learned it. It's been a couple days, and that's why we take notes. So just feel free to flip back one page. We wrote that down a couple different places last class. If you were absent last class, this is a great opportunity for you to get caught up on what you missed. Key idea from last class was that in these equations, this number represents the change, and this number represents the starting value. The starting value always happens when x is equal to 0. So can you spot the starting value in this table? What is it? 2. My starting value is 2. I like drawing arrows. And then the change, how do I find the change? I just need to figure out how my y values are changing. What is my change in y? Plus 5 or minus 5? Plus 5. I agree. Plus 5, plus 5, plus 5. It's consistent, so that gives me my change, which goes right there. And there's our equation, 5x plus 2. Another quick review. Is this a function? Does each input only have one output? Sure is. Yes, it is a function. They're asking us to write the equation in function notation. Oh man, that sounds tricky, doesn't it? It's not. It's not. It's going to look exactly like this, except instead of a y, you're going to have f of x. Same equation. Still 5x plus 2, still an equal sign. Just leave the y out and give me an f of x instead of a y. F of x is the same thing as y. It's just function notation. So f of x equals 5x plus 2. That wasn't too bad. Bless you. All right. So now that we've reviewed how to write these equations, we are going to make some equations for some lines. So follow along with me, please. I need to find a starting value for this line. Starting value always happens where x is equal to 0, which is right here. Can you find me a point on this graph that has an x value of 0? Yeah, right here. This point has an x value of 0. It has 0, 3. So 3 is going to be our starting value. When we do starting value is always where x is equal to 0. Scratch out this 1 and this 2 here. We don't need those. We're just going to count. Can you tell me how much this graph is changing? How much is this graph changing? So as it goes from here to here, how much is the y value changing? 2. It's growing by 2. If you've got a starting value and a growth, you should be able to write me an equation. Can you write me an equation, please? Y equals, it's going to have a 2 and a 3 in it. It's also going to have an x. We just got to get everything in the right place. Again, feel free to take a glance at your notes if you need to. Is it 3x plus 2 or is it 2x plus 3? 2x plus 3. Starting value goes without the x. All right, see if you can do something similar on this next one. Can you find me a starting value? I agree. Starting value appears to be 9. Can you tell me how much is changing by? What's our growth? It's going up by 12. Write me an equation with that 9 and that 12. And then I want you to try the third one on your own. You got this. I do, and someone's out right now. It lives back there, so just keep an eye out. When it comes back, it'll be next. Or wait, is someone out? Yes. He just left a moment ago, but he shouldn't be too long. Are you able to wait? Okay, thank you. All right, let me catch up to you guys. You're moving quick. Starting value goes here, growth goes here. This one seems like it starts at 3, and it's going up 1. Growth of 1. Growth is 1, starting value is 3. Yeah, I think we're good. I skipped the function part. Do these graphs pass the vertical line test? I think they all do, don't they? If I sweep my vertical line across, it's never going to touch the graph in more than one spot. So yeah, lines are typically functions. Almost all lines are functions. Almost. Okay, flip over in the back. Our big learning target for today is going to be with the slope triangles. We're actually going to get to positive and negative slopes in the next lesson. Let's talk about what a slope triangle tells us. So when I look at this triangle here, this tells me how much my x value is changing. And that makes sense that that's plus 3, right? Because this one's going from 4 to 7. And to go from 4 to 7, you would do plus 3. Agreed? So my change in x, could you guys write this down on your paper? My change in x is 3. Could you tell me what my change in y is? Well, it looks like it's 27. So that's my change in y. And does that math line up from 31 to 58? Is that 27? I believe it is. 31 plus 27 would get us to 58. Okay, so when we do a slope or a change, and we've got a graph where the points aren't right next to each other, we have to rely on this change in y and change in x. And this is the big thing for today that I totally screwed up on the learning targets page. I had it backwards. Slope is always change in y over change in x. In this case, our change in y was 27, and our change in x was 3. (27 over 3). Does that simplify? What is 27 divided by 3? 9? So our slope is 9. It's change in y over change in x. What do you think? Now, what does that 9 mean? What that 9 means is if I did have 2 points that were right next to each other, to go from this point to this point, I would need to go up by how much? By 9. If those points had been right next to each other, they would have been 9 units apart going up and down. All right, let's see if you can give me some values for this one. Can you write down what our change in x and our change in y are for this graph? They didn't give us numbers, but we can count. We got this. Change in y is 2, and change in x is 1, 2, 3, 4. Make sure you're counting spaces. Don't count grid lines, count spaces. So 2 spaces up and down, 4 spaces left and right. Could you please write me our slope? It's going to be a fraction. It's going to have a 4 and a 2 in it. We just need to get the right one on the top and the right one on the bottom. Did you get them in the right place? What would you guess the most common mistake when people make when they're writing slopes like this? Flip them, totally. At this point, the most common mistake is going to be flipping the numbers, not putting the y value on the top. Second most common would be not reducing. We want to reduce if we can. Does 2 over 4 reduce? What can we divide both 2 and 4 by? We can divide them both by 2. That'll reduce that fraction. That'll become 1 over 2. So our slope would be 1 over 2. And again, what does that mean? That means if I had 2 points that were right next to each other, that to go from one point to the other, I would need to go up by a half. All right. We are going to find slope for triangles A and B here. So let's go ahead and do this. I'm going to walk you through A and then ask you to do B, and then you're going to come down here and do C as well. All right, so let me look at A. So I want to do change in y over change in x. It's definitely 6 and 4. I just need to make sure I get the right one on the top and the right one on the bottom. We want change in y over change in x. So 6 over 4, and I believe that simplifies, doesn't it? Those are both divisible by 2. They're both even. It was reduced to 3 over 2. Slope for line A is 3 over 2. Could you please find me the slope for line B? I'm hoping we came up with the same fraction. Yep, that's good. That's good. Because you know what? It doesn't matter where you find slope on a line. It's always going to be the same. So we found the slope from here to here in A, but it's on the same line. It does not matter which 2 points I pick to make a slope triangle and find a slope. We're always going to get the same answer. It will always come out to be 3 over 2. By the way, what is 3 over 2 as a decimal? What's 3 divided by 2? 1.5. This would be another way to write our slope. We could write it as 1.5. Slope can either be a fraction or a decimal. So in part C, or for triangle C here, they want us to figure out what goes on the top of our fraction. What is change in y? We know the change in x is 3. We can see it right here. They're asking you to figure out what goes up top here. And we know that it needs to come out to equal 1.5. So if you need to, feel free to use your calculator, but find me a number we could put on top of that fraction that when I divide it by 3, I would get 1.5. I'll give you a hint, it's going to be a decimal. I don't see nearly enough people reaching for their calculators right now. I'm totally okay with you doing it in your head if you can. What is it? I'm going to try it. 5 divided by 3. I like the guess, but that is not 1.5. Grab a calculator. Try something else. Folks, get your calculators out, please, right now. Get them out. We got a suggestion of 4.5. Another suggestion of 4.5. Does 4.5 work? We got it confirmed. Yes, yes. 4.5 divided by 3 is 1.5. Okay, all right. So it must be 4.5. Does it look like it's 4.5 if I count spaces 1, 2, 3, 4 and a half? It kind of actually looks like it's 4.5, doesn't it? All right, we're going to skip part C there for now, and we'll call this quits for today. Guys, our big learning target for today was about slope triangles, and the really big takeaway I want you to take away today is that if I'm looking at one of these slope triangles, and I want to find the slope from it, it's change in y over change in x. You learned probably slope using 2 R words instead of change in y and change in x previously. What were those 2 R words? Rise and run, right? You learned rise over run. Do you see how rise over run is just kind of a simpler version of change in y over change in x? If your y value is changing, you're rising. And if your x value is changing, you're moving to the side. We call that run. Okay, so this change in y over change in x is just kind of a more formal way to say the same thing that you already knew as rise over run. All right, we're not going to score ourselves on a learning target yet today because we still need to come back and talk about positive versus negative slope. If you did not already, please score yourself on the learning targets for 2.1.1. And the big thing there was, can you write an equation and figure out where the change and where the starting value goes? All right, guys, I'm going to get you your assignments.